Hello, welcome to Astronautics for Exploit. This is Dr. Anshola Ogundele. Celestial and interplanetary space gas stations and in-orbit refueling, once a pie in the sky, now made possible by technological advancement. The focus points are as follows: spacecraft refueling and spacecraft in-orbit refueling concepts and technology demonstration. Celestial and interplanetary space gas stations and in-orbit refueling, which was once a pie in the sky, and the science fiction is gradually becoming a reality. This can be attributed to the reduction in spacecraft launch presses and the use of small satellites for rendezvous and proximity operations, in contrary to the conventional large satellites. Presently, efforts are being undertaken to send gas stations into space. The gas station spacecraft will orbit the Earth and be able to fly to refuel other ships in Earth orbit, such as low Earth orbit, medium Earth orbit, and geostationary Earth orbit, celestial bodies, and interplanetary space. A breakthrough in the design and development of celestial and interplanetary space gas stations and in-orbit refueling was achieved with the successful launch of the Mission Extension Vehicle. The MEV, small-scale in-space satellite refueling mission, was designed to dock to geostationary satellite, whose fuel is nearly depleted, so as to extend the functional lifetime of the spacecraft. It uses its own thrusters and fuel supply to extend the satellite's lifetime. Several spacecraft in-orbit refueling concepts and technology demonstrations have been proposed and demonstrated. Examples are robotic refueling mission, space infrastructure servicing, space talk alternatives to direct refueling, Orbital Express, MDA in-space refueling demonstration project, superfluid on-orbit transfer, flight demonstration, and a host of others. The robotic refueling mission is a NASA technology demonstration mission with equipment launches in both 2011 and 2013 to increase the technological maturity of in-space rocket propellant transfer technology by testing a wide variety of potential propellant transfer hardware of both new and existing satellite designs. A series of robotically actuated propellant transfer experiments were successfully completed on the exposed facility platform of the International Space Station in January 2013. Spacecraft refueling. Spacecraft are sent into space by a rocket launched from the ground with enough energy to get outside the Earth's atmosphere. Once the rocket reaches its determined location, it drops the spacecraft into its orbit. Spacecraft orbit around the planet, for example the Earth, because they are locked into space that are fast enough to defeat the downward pull of gravity. The fuel on board the spacecraft is used to maintain its orbit over its orbital lifetime through station keeping. Illustration of this space satellite NOAA's, whose orbit is about 1 million miles from the Earth, is shown in this picture. Spacecraft refueling is the process of replenishing onboard propellants and other consumables in spacecraft orbit. For example, in geostationary orbit, on-orbit refueling of spacecraft has been proposed as an alternative to the exclusive use of heavy-lift launch vehicles in order to enable human exploration beyond low Earth orbit. Orbit 5 refuel satellites is shown in this picture. Spacecraft refueling concepts are potentially attractive because they reduce the maximum individual payload that must be placed in Earth orbit. However, they add significant complexity to mission operations and introduce more uncertainty and opportunities for failure to the mission. Instead of launching transportation elements fully fueled, on-orbit refueling allows the elements to be launched dry at only a fraction of the total fuel mass. Propellant is then launched on one or more additional launch vehicles and transferred to the element in low Earth orbit. Illustration of astroscale in-space refueling services is shown in this picture. Spacecraft in orbit refueling concepts and technology demonstration. The concepts and demonstrations. Several concepts of spacecraft refueling approaches had been proposed, and some of them had also been demonstrated. Government space agencies, private space companies, and investors are contributing immensely to the research and development of spacecraft refueling approaches and technologies. The picture here shows sample rendering of Sloan Tech extracting lunar resources in order to produce rocket propellant. Examples of spacecraft in orbit refueling concepts and technology demonstrations are robotic refueling mission, space infrastructure servicing, space dock alternatives to direct refueling, orbital express, MDA in-space refueling demonstration project, superfluid on-orbit transfer flight demonstration, and orbital refueling system flight demonstration. Robotic refueling mission. Since 2009, advancements have been made in the robotic technologies for a notional free-flying servicer spacecraft, which could access, repair, and refuel satellites in geosynchronous Earth orbit. Through RRM, efforts are being made to add precious years of functional life to spacecraft and expand options for operators who face unexpected emergencies, tougher economic demand, and aging fleets. The picture here shows robotic refueling mission. The robotic refueling mission is a NASA technology demonstration mission with equipment launches in 2011 and 2013. A series of robotically actuated propellant transfer experiments were successfully completed. Illustration of NASA's first robot servicing demo at space station is shown in this picture. The robotic refueling mission was planned to demonstrate technology and tools to refuel satellites in orbit by robotic means. The experiment shoot included propellant valves, nozzles, and seals, and a series of 4 prototype tools which could be attached to the distal end of the destroyed robotic arm. Canada's robot performing satellite refueling is shown in this picture. Space Infrastructure Servicing is a spacecraft contest being developed by Canadian aerospace firm MDA in order to operate as a small-scale in-space refueling depot for communication satellites in geosynchronous orbit. The design idea was to be a single spacecraft that would refuel other spacecraft in orbit as a satellite servicing demonstration. Testing of new technologies for robotic refueling is shown in this picture. The technical design of fuel depot vehicle that will maneuver to an operational communication satellite, dock at the target satellite's apogeic model, remove a small part of the target spacecraft thermal protection blanket. The proposed business model for the service was to ask customers to pay per kg of fuel that was successfully added to their satellite. Illustration of in-orbit servicing mission is shown in this picture. Space infrastructure servicing is another in-orbit refueling concept. In addition to refueling and servicing geostationary communication satellites, with the fuel that is initially launched with the vehicle, the space infrastructure servicing vehicle is being designed to have the ability to orbitally maneuver to rendezvous with a replacement fuel canister after deploying 2,000 kilograms of fuel in the first load. Further refueling of additional satellite after the initial multi-satellite service mission is then complete. The obvious general expansion architecture design is shown in this picture. Space dock alternatives to direct refueling. A space dock is a spacecraft that can be used to transport satellites from low Earth orbit to higher operational orbit. It will help to reduce the platform mass in favor of larger payload mass. The interest of space agencies and companies in space talk is because of its applications in orbital payload transfer, in-orbit refueling, and a host of others. Artist's concept of the Helio space talk is shown in this picture. In 2015, Lockheed Martin proposed the Jupiter space talk. The idea involves that Jupiter will operate in low Earth orbit, shuttling cargo carriers to and from the International Space Station, remaining on orbit indefinitely and refueling itself from subsequent transport ships carrying lighter cargo carrier modules. The picture here shows a Lockheed Martin cargo vehicle consisting of a reusable tug called Torpedo and a cargo module called Exoliner. Presently, there are various proposals and design of reusable space tug for satellite servicing and refueling. Space tug alternative to direct refueling involves bringing additional propellant to a space asset and using the propellant for altitude control or orbital velocity change without ever transferring the propellant to the target space asset. Concept illustration for a low Earth orbit depot and reusable space tug is shown in this picture. Orbital Express is another in-orbit refueling concept. It was aimed at developing a safe and cost-effective approach to autonomously service satellites in orbit. The system consisted of two spacecraft, the Astro Servicing Satellite and the prototype modular next-generation serviceable satellite. The project hoped to demonstrate several satellite servicing operations. Orbital Express Astronaut Nesta is shown in this picture. Superfluid on-orbit transfer flight demonstration was proposed in 1984 to carry out a series of tests of technology and physics required to store and move liquid helium from a large depot into individual dewars above various satellites. Superfluid helium on-orbit transfer flight demonstration is shown in this picture. The objective of superfluid on-orbit transfer flight demonstration are transfer of superfluid between two dewars in a low-gravity environment, operation of two different liquid acquisition devices within the dewars, liquid vapor phase separation for normal liquid helium, accurate mass gauging and flow metering, and autonomous control of the transfer process. The picture here shows NASA's satellite refueling robot platform. The orbital refueling system flight demonstration was a low-cost system which is used to demonstrate propellant transfer. It was a demonstration of shuttle human-tended capabilities to refuel already orbiting satellites once their self-contained thruster systems have depleted fuel reserves. This demonstration is a precursor to actual shuttle refueling missions for satellites. Northrop Grumman's orbital refueling concept is shown in this picture. For more information, contact Astronautics for Exploit. You've been listening to Celestial and Interplanetary Space Gas Stations and in-orbit refueling, once a pie in the sky, now made possible by technological advancement. Presented by Dr. Ayeshola Ogundele, with its focus point spacecraft refueling and spacecraft in-orbit refueling concepts and technology demonstrations. Thank you.